So this is the 2014 Junior Cert Higher Level Paper 2, and we're looking at question number 7. The diagram below shows part of the frame of a swing on a coordinate grid. Each unit on the grid represents 1 meter. The line segments AB and AC represent metal bars. So here we have AB and AC. Part 1 says write the coordinates of the points A, B and C in the spaces provided in the diagram. So the point A, starting at the origin, you go 0, 5. So the coordinates of A are 0, 5. To get to point C, you go over 4, and you don't move up the y-axis, so 4, 0. And to go to B, it's minus 4 and 0 up the y-axis. So that's the 3 coordinates. Part 2 says find the total length of metal bar needed to make this part of the swing. Give your answer in meters correct to 1 decimal place. Okay, so we can find, using the distance formula here from the tables book, we can find the length of AC. And we can see that AC is going to be the same length as AB because they both go over 4 units, left and right. So A is 0,5 and B is 4,0. So A is 0,5 and B is 4,0. So I'm going to call this point x1, y1 and this point x2, y2. And then I'm going to substitute these values into the distance formula. So x1, which is 0, will go in here. y1, which is 5, will go there. x2, which is 4, will go here. And y2, which is 0, will go there. So substituting them into the formula then, I'm going to get that AB, the length of AB is equal to the square root of the blue minus the yellow, so that's 4 minus 0 squared, plus the pink minus the green, so that's 0 minus 4 squared. So when you put all this here into the calculator, you end up with root 41. So root 41 is the length of AB, but then we're going to double that for the length of both bars, which is the total length of metal for the swing. So twice root 41. And that gives us, on your calculator now, you can try this. So it's 2 root 41, which is 12.806, and on it goes. But we want our answer correct to 1 decimal place. So we're going to look to the second digit after the decimal. Does this 0 affect the 8 in front? The answer is no. So we're going to say it's 12.8. And that's going to be in meters. I think, does it tell us the units? Yeah, each unit on the grid represents 1 meter. Okay, so that's going to be 12.8 meters to the nearest decimal place, to 1 decimal place. Okay. Part 3 says find the slope of AB and the slope of AC. Alright, well the slope of AB, we're going to use the slope formula here, which I've taken from the tables book. So again, using the same, for the slope of AB, I can use the same color coordination here. And I'm just going to sub those values in here. So the yellow, x1 will be down here. Green will be y1, which is there. The blue will be x2 down here, and the pink will be y2, which is up there. So this is for AB, which is the slope of AB. So the slope of AB will be the pink minus the green, so that's 0 minus 5 on top of the fraction over the blue minus the yellow, which is 4 minus 0. And that gives us a value of sorry, I've just realized there that the point B was actually, that was the point C there that I marked down. So the point C there was that one. So this was the length of AC. It doesn't affect the answer because AC and AB were the same. So for here, AC is this one here. So AC would be the pink, which was the 0 minus the green, over the blue minus the yellow. So that gives us minus 5 over 4. So that's the slope of AC. AB then, well, the point A is 0, 5, and the point B is minus 4, 0. Okay, so again, color coordinating this, you've got these values to plug in. So the slope will be the pink minus the green, so which is 0 minus 5. 0 there. 0 minus 5 all over the blue minus the yellow, which is minus 4 minus 0. And put this in a calculator, you get 5 over 4. So the slope of AB is 5 over 4, and the slope of AC is minus 5 over 4. Part 4 says, is AB perpendicular to AC? Give a reason for your answer. Well, if they're perpendicular, you can multiply their slopes and get negative 1. So if we just try this, multiply 5 over 4 by minus 5 over 4. You can do this on your calculator if you like. But the answer you get is minus 25 over 16. And that is not equal to minus 1. So the answer is no. They're not perpendicular because of this reason. Part 5 says, Madison draws the scale diagram of the triangle OAB, shown on the right. So here's the triangle. She marks in the angle X. Recall that AB is a metal bar, so this is AB, which is part of the frame of the swing. Write down the value of tan X and hence find the size of the angle X. Alright, well tan X, we can see here, if we look at the tan, this is from our tables book, this section here. We've got the angle A, the tan of A, that matches our angle X here. Well, the tan of A is small a, which is the opposite side, which for us will be 5, over B, small b, which is the adjacent side here to the angle, which in our case will be 4. So the tan of X, which is yellow, is equal to the green over the blue. So it's equal to 5 over 4, in other words. Okay, so if the tan of X is 5 over 4, well, the angle X then will be the inverse tan of 5 over 4. So the inverse tan of 5 over 4, that's equal to, you do this in your calculator, make sure your calculator is set to degrees, and you get 51.340, and on it goes. But they want the answer, the angle correct to 2 decimal places. So we're going to look to the third digit after the decimal. Does this 0 affect the 4 in front? The answer is no. So it's going to be 51.34 degrees for the size of the angle x. And finally, part 6. In order to increase the height of the swing, it is decided to increase x, the angle, by 20%. The distance AB will be kept the same. Find the new height of the swing. Give your answer in meters, correct to 1 decimal place. Okay, so the distance AB will be kept the same. So let's go back. The distance AB was, well, root 41 was the distance AC, which is the same as AB. So root 41 is the distance. And then the angle, which was 51.34 degrees, is going to be increased by 20%. So if I draw just a diagram now, I'm going to have a triangle like this. I'm going to have a new angle x, which I'll call x dash. I'm going to have, this is, sorry, right angle triangle. This is x dash here. This is our point A there, our point B here. And we know that that length is root 41. That's been kept the same. So we've defined the new height of the swing. The height would be this distance here, h. Okay, so x dash, the new angle, will be equal to the old angle, x, increased by 20%. Now if you increase it by 20%, that means you multiply it by 1.2 or by 120%, because if you increase it by 20%, you're adding 20% onto 100. So that will be, x was 51.34. So 51.34 multiplied by 120%. You can do this on your calculator using the percent button, or you can multiply it by 1.2, same thing. Either way, you get the answer of 61.608 degrees. So this is the new angle. Okay, so then this is x dash down the left. So now that we have this here, we can look at this and we can see I've got this angle, I've got the opposite, and the hypotenuse. In other words, I've got the angle, the opposite, and this time the C value. So from the tables book, you can figure out if it's A over C, that's going to be the sin of A. So it's going to be the sin of the angle. So the sin of x dash is equal to the opposite, h, that we're looking for, over the hypotenuse C, which in our case is root 41. So what we have then is that the sin of 61.608 degrees is equal to h over root 41. And if we want to find h then, we're going to have to multiply these two values here. So h will be root 41 multiplied by the sin of the sine of 61.608 degrees. Should really be a bracket there. So that's how we find our height, the new height of the swing. So when we do that, we get an answer of, in our calculator, 5.632, and on it goes. But we want our answer in meters, correct to 1 decimal place. So I'm going to look to the second digit after the decimal. Does this 3 affect the 6 in front? No. So it's going to be 5.6 meters. So that's my answer for the new height of the swing, correct to 1 decimal place, and that's the end of question 7.